Many products when purchased provide health information including the quantity of total fat, sugars, etc. However, many do not provide the total amount of calories per quantity, particularly that of uncooked materials such as that of raw beef products used in burgers. It is more logical to predict the calories from the total fat, as fat is normally already given or is easily calculable and therefore is a more easily attainable number. In this data set, the independent variable is the fat and the dependent variable is the calories, so the fat is plotted on the horizontal axis of a graph and the calories on the vertical. Information regarding the individual burgers was collected from various restaurant websites and sorted into the table from least to most fat content. The graph was then drawn using the built-in scatter plot creation tool within Excel, where the line of best fit was added and the option to display the equation of said line was enabled to provide the equation to me for use in later questions. The data on the scatter plot follows that of a moderate positive linear association, where it is linear due to the linear or straight line nature as indicated by its increase at an approximately constant rate. As it is increasing in a positive direction from left to right, it is also positive, as there is a definite positive trend with the points being slightly spread. It can be concluded that this is therefore a moderate correlation. This is further reinforced by the Pearson's correlation coefficient calculated later in question 5, where the value is within the moderate range being greater than or equal to 0.5 and less than or equal to 0.75. The gradient of the line is able to be interpreted from the equation y equals 11.1x plus 187. It is in the form y equals mx plus b, where m is the gradient and thus the gradient is 11.1. The total calories at a fat level of 50 grams was found through the substitution of the value for fat into the x value within the equation, making it y equals 11.1 times 50 plus 187 before solving for y algebraically, resulting in a value of 742 calories. Similarly to the previous question, the equation of the line of best fit is once again used to find the value of calories as a given fat being 25 grams. Linear interpolation was performed by substituting into the equation, making it y equals 11.1 times 25 plus 187, resulting in a value of 464.5 calories. Once again, the line of best fit can be used to extrapolate. However, in order to view this data, the line of best fit was extended, showing the estimated values outside of the existing data set. Again, through substitution, making the equation y equals 11.1 times 3 plus 187 and solving resulted in calories value of 220.3 at 3 grams of fat. For question 4e, there are limitations with this model as there may be unknown trends beyond that of the current dataset. Fat and calories may not always be in a linear relationship outside of this dataset, and hence it is not reliable to perform extrapolation on this. Pearson's correlation coefficient was calculated using the correl function. The Excel correl function calculates the Pearson correlation coefficient for two sets of values, in this instance being that of the two sets of data collected, the X range of fat and the Y range of calories, outputting the correlation coefficient of 0.7322568,732 of these two ranges. To perform this calculation in a blank cell, I entered the following, as found in cell A18. This cell shows the correl function being used for the X range of C2 to C15 and the Y range of B2 to B15, outputting the value of 0.7322568,731, which is that of a moderate positive linear association.